Welcome everyone to part 2 of Ultra 10539's Introduction to me, I'm Washu, one of the software leads for the team. Last video, you may recap that we introduced you to the FTC SDK and how to set up GitHub for your specific computer. Today, we'll begin by actually building a hardware map for all of your motors, servos, and sensors. If you're new to FTC, you may be wondering what a hardware map actually is. Our hardware map is a Java class that defines all the specific hardware components for a single robot. In this case, we'll be assuming that your robot is a pushbot. The hardware map for FTC assumes that the device's names have been configured on the robot either to the robot controller or the driver station phones. Now that I've explained what a hardware map actually is, let's begin by actually creating one. Here, you'll see that I've opened up our Android Studio project. Then, I click on Team Code, and if you see your Gradle build is finished installing, you will find a Java package named org.firstinspires.ftc.teamcode. Click on that, and you'll be welcomed with readmd.md file. From there, to separate our code into folders. To do this, right-click on the org.firstinspires.ftc.teamcode package, click on New, then select Package. Then you can name your folder whatever you want. For this case, we'll do robot data. Then I'll click enter, and it should create our package. Then we'll want to create on the robot data package, and click on new again, and click on new Java class. From here, we can name it hardware map or device map, and I'll name it device map, of course, following camel case. Once your file has been created, you'll see something on the lines of, do you want to add the following file to Git? In terms of simplicity's sake, I like to do it, so you can click on add. Package name, and then the public class device map. Now we'll want to declare our op mode members. Op mode members are the variables, are the methods of the Java class. We'll be assuming that you have a 4-motor setup. So what we can do is public DC motor left front equals null. This means that we've just declared a DC motor called left front into our device map. Now you may be receiving a red error for DC motor, and this is because we have to import specific files that the FTC, the First Tech Challenge organization, has already created for us. And to do so, we can right-click on DC motors, click on Show Context Actions, and click on Import Class. Then we can do the same for the other 3 motors on our robot. So public DC motor right front equals null. Then we can do it for the back motors. DC motor left bottom equals null. Public DC motor right bottom equals null. And we'll also be assuming you have a servo and 1 distance sensor. So we'll also be doing public servo left claw is equal to null. We'll also be doing public distance sensor. And you'll know, like with DC motor, servo and distance sensor are not imported classes, so we'll have to do that using show context actions and import our class. Then we want to declare our other op mode members, including our actual hardware map for our op modes and our elapsed time period. This will allow us to communicate with our driver station and robot controller phones efficiently. So to do this, we would do hardware map HW map is equal to null. You'll see, similar to the VC motor, servo, and distance sensor, our hardware map is labeled red. To do this, we can import the class. Then we will establish a private elapsed time period. So we do this by declaring elapsed time. Then we want a special method that is used to initialize objects when we call or /declare our device map in our op modes. To do this, we can do public device map and 2 brackets. Then we want to create a init function that will allow us to initialize all of our devices in our robot and set them up with the correct settings. We'll be providing you with the default settings, but you can choose to change these settings if you wish to do so, using the FTC SDK documentation. So we'll write a method called init, public void init, hardware map, and we will now declare all the members that we've just declared. So left front is equal to HW map dot get DC motor dot class left front. Now this name that you've just declared left front for the device name for DC motor class has to be the same name that is in your robot controller or driver station configuration. So we can do the same thing for all of the three of the motors. The get DC motor dot class right front. To make things more efficient, we can copy and paste the code that we've just written for both the top and the bottom, for both the left and the right, and then change the code from left front to left bottom, and from right front to right bottom. We can also change it here. Then we can also declare our rev 2 meter distance sensor. So rev 2 meter distance sensor time of flight in equals to rev 2 meter distance sensor. What we're doing here is casting the distance sensor into a rev 2 meter distance sensor object so that we can obtain many more functionalities that we usually wouldn't get. Then what we can do is set the power for all of our motors. So left front dot set power is equal to 0. Right front dot set power is equal to 0. Left bottom dot set power is equal to 0. Right bottom dot set power is equal to 0. And we can also tell the left front and all the other four motors to run without encoders. To do this, we would do left front dot set mode DC motor dot run mode dot run without encoder. If you want to use encoders, you can do so. However, for right now, we'll be running without encoders. I'll be doing the same thing that I did for our device map initialization, which is copy our code 3 times, rename the code, and make our code much more efficient in terms of time consumption. We'll also need to talk about our left claw, so hardware map dot get servo dot class left claw. Now that you've added a new file to your object, your fellow teammates that work on different computers will need to receive that file so that all of you are working on the same codebase. As introduced in the last video, you'll be using GitHub for this. Today, and for a majority of this time, you'll be using GitHub for this project. It will be pretty simple. Just to reiterate what has been said previously, this is how you should push your work to an online repository. You can do git add dot but test. And then I will have a git commit message saying test. Then what we can do is git push -u origin master. And this will now push our code to our repository. Then there we have it, a basic device map that can get your team started with learning how to use it and program the devices. That is it for part 2. For part 3, we'll be teaching you how to create a basic teleop drive using this device map that we have just created. Thank you.